In this section, what we're looking at is solving systems of equations, otherwise known as simultaneous equations. All right, so here it is that we have two cases. We have x plus 2y equals 7, which is equation 1, and 3x minus 5y equals negative 12, which is equation 2. All right, what we're going to be using is the elimination method, one in which we are going to actually eliminate one of the variables so that we could focus on the other one. So we're either going to eliminate the x's and focus on the y's, or we're going to eliminate the y's and then focus on the x first. So let us say that I intend to eliminate the y's. If I'm going to eliminate the y's, all I have to do is to focus on, there are many ways we can do it, but one of the easiest ways is to create two more equations, right? So that's the standard way that you could do it. We could create two more if we want by focusing on the coefficients of the variable that we want to eliminate. So we want to eliminate the y's. We're going to focus on the coefficients, which are, there's a 2 and there's a 5. At this moment, we don't have to worry about the negative or the positive, really. So what we're going to do is to multiply each one of the equations in creating the third and the fourth. So if you notice, the 5 is in equation 2. We're going to use it in equation 1. And the 2 is in equation 1. We use it in equation 2. What am I referring to? Let's point at them quickly. This 2 is in equation 1. I'm using it to multiply by equation 2. This 5 is in equation 2. I'm using it to multiply by equation 1. So that's what we're going to do, all right, in order to get back the same number. So let us carry out the operation now. So 5 times x, so I'm going 5 here, times x, and that's going to give me 5x. 5 again, times 2y, that's going to give me positive 10y. 5 times 7, and that's going to give me 35. This is equation 3. Equation 4, we're going to use 2 times 3x, and that's going to give 6x. Then 2 times negative 5y, and that's going to give negative 10y, which is equal to 2 times negative 12, which is going to give negative 24. And this is equation 4. So at this moment, the focus is on equation 3 and equation 4. Remember, we had decided to eliminate the y variable. So if you look at it, we have a positive 10 and a negative 10. So if we should take it aside, if I have a positive 10 and if I have a negative 10, what can I do to this so that it's completely eliminated to get a 0? You'll definitely see that if I add these two numbers, we will get 0. So adding equation 3 to equation 4 will help us now in eliminating the y variable, which was what we wanted to do. So we could write a note that we want to add the two equations. We could draw a line, depending on how you want to do it. So if I could draw a line here, since we're seeing that the variables are lined up. So if I say 5x plus 6x, I'll get 11x here. Negative 10 plus positive 10, that's a 0. 35 plus negative 24 will give me 11. So at this moment, we have 11x is equal to 11, and that's when we add the two equations. Basically, if I divide by 11, x is equal to 1. Now that I know that x is equal to 1, I can use this now to help me in any one of the 4 equations to find y. So let us say that I want to substitute. At this moment, I can, because there are many things that you can do. But I could substitute 1 for x, and I could do it in equation, say equation 1. So I'm going to write my equation 1 up here. So equation 1 is x plus 2y, which is equal to 7. But remember that I know that x is equal to 1. So then I could say 1 for the x plus 2y is equal to 7. At this moment, I'm solving. So I'm going to subtract 1 from both sides. So then 2y is equal to 6. Then if I divide by 2 both sides, then y is equal to 3. Let me just finalize that x is equal to 1 and y is equal to 3. So that's using the elimination method at first to eliminate one of the variables. And then I could just substitute that value in any one of the equations to find the next variable. If it was graphically, this would have been our equation 1 here, which would be the x plus the 2y, which was equal to 7. And this was our equation 2, which was actually the 3x minus 5y, which was equal to negative 12. So these were our two equations. And if we should look carefully, this is where they actually intersect right there. So this, the coordinate of that point you could see is where the 1 meets 3. So 1, 3. And this is the x coordinate and that's the y coordinate. So when you solve a system of equation or a simultaneous, linear simultaneous equations, we're looking at where the two lines intercept each other and you're reading off the coordinates. So that's what we just found just now. Let's go back to another one, right? At this moment, we have 4x plus 3y, which is equal to 1, and then 3x plus 2y, which is equal to 1 as well. We're still going to be using the elimination method first. So let us say I want to eliminate the x this time. So I'm going to be eliminating the x. Now, in eliminating the x, I'm going to be focusing on the coefficients here, the 3 and the 4. All right, so let's label up. This is equation 1 and this is equation 2. Now, I am going to use 3, which is from equation 2. I'm going to use that to multiply by equation 1, and 4, which is from equation 1, I'm going to use it to multiply by equation 2. We're going to create 2 more equations. So let's go. 3 times 4, that is 12x. 3 times 3y, that's going to give me 9y, which is equal to 3 times 3, 3 times 1, which is 3, and this is equation 3. For equation 4, this is 4 times 3x, which will give us 12x, 4 times 2y, which will give us 8y. This is equal to 4 times 1, which will give us 4. This is equation 4. All right, so there it is. We have all 4 equations. So the aim is to focus on equation 3 and equation 4. We're looking at the x variables. So we're seeing 12x and 12x. So we're seeing 2 positive numbers, positive 12, and there's a positive 12. What can I do for this to be equal to 0? I either add or subtract. If we add, that will be a 24, so that would not work. So at this time, we're seeing that when we subtract 12 from 12, we do get a 0. So it means then that we need to be subtracting the 2 equations. Remember that whenever you're subtracting, you have to link same, or what we call like terms. So basically, I'll say 12 here minus 12, that's a 0. So this part is actually gone. But if I have a 9, and then I'm going to subtract 8, then I am looking at y. We might say 1y, but we don't write 1 in front of a 0. 3 minus the 4 is a negative 1. if you notice, I was putting the top numbers first all the time. So you have to be consistent with it. You could have always used the bottom number first, but be consistent with it. Right? So as long as you're consistent with what you're doing, it's fine. Right? So y is equal to -1. Now, if I know that y is equal to -1, I can now substitute -1 for y. And I could do this in any one of the equations. I'm going to put in equation 1. So let me write equation 1 up here. It says 4x plus 3y is equal to 1. Remember, though, that -1 is equal to y. So I'm going to be substituting -1 where y is. So this is actually 3 times y. So it's going to be 3 times -1. And this is equal to 1. In simplification, 4x minus 3 is equal to 1. Now we're going to be adding 3 to both sides. We're solving for x. 4x is now equal to 4. And if we divide by 4, x is equal to 1. Conclusion, x is equal to 1. Y is equal to -1. So what this means is that if we look at the graph, these two lines will cross each other at the coordinate 1, -1. Let's take a look. All right, so here is equation 1. That's equation 1 right there. So this is the 4x plus the 3y, which is equal to 1. And here is equation 2 right here. And this is the 3x plus the 2y, which is equal to 1. And this is where they intercept right there. You look, this is where 1 meets -1. So the coordinate is 1, -1. All right. So here are the numbers right there, right there. So that's what we're saying, that when you solve linear systems, you're actually looking for where the two lines intercept each other. The coordinate is the solution. That's the x and that's the y. All right, so there you go. Look out for the next method. We will be coming with substitution method after this fully. And in that method, you will substitute 2 times. See you next time.